you've got some nutrients inside the body. At that point, they're floating around in the bloodstream. And we can talk about metabolic fates of these things. When we talk about metabolism, we're talking about every possibility. It's not just breakdown of its so-called catabolic reactions, breakdown ones. It's also anabolic. It's everything together. There's probably hundreds, thousands of pathways. They're interconnected with each other. There's lots of potential fates for any particular molecule that enters into our metabolism. But just in a gross sense, you can break it down into the catabolic reactions and anabolic reactions. These are, the catabolic ones are degradative in nature. So you start with something big and chop it up into small things. That's catabolism. More often than not, not always, but more often than not, in addition to chopping it up, you're oxidizing it. That is stripping electrons out of it. The other half of that coin are the biosynthetic reactions, collectively known as anabolism. And you're building up more complex things from simpler precursors. And again, more often than not, you're adding electrons to it. You're reducing those small molecules as you build a more complex thing. That's metabolism. We talk about metabolic pathways. A pathway would be one individual road on this map of possible sequences. So a metabolic pathway is a sequence of consecutive reactions where, let's say we start with this guy, it gets converted to that by one enzyme. That intermediate gets converted to another one by a second enzyme. And you string together, a half dozen of these different enzymes, you get the desired end product. We would call this a metabolic pathway. This one is linear. You can have the branch. Maybe there's two possible fates there. This one could go that way. Maybe it could go into a different alternative product if you want. Sometimes they're even circular. And we'll see with the Krebs cycle in the case of a circular pathway. From a thermodynamic standpoint, you start here, you go to there. It's a one-way trip. These pathways are unidirectional, not reversible. So you can't start here and go back up there because this is higher energy. That's true of any metabolic pathway. They're all one-way roads.